Thank you so much. First, I'd like to extend a sincere thanks and appreciation to CSPPLAZA for putting together a really well organized and curated event. This has been a really productive past 2 days, and so I want to thank you. I also want to thank the few people left in this room. I know it's late, and the few folks here left who are still awake. Appreciate you sticking around for this presentation. Today I'm going to talk about something that's really important to me and our organization, which is reducing the cost of parabolic trough technology here in China. This is important for a variety of reasons that I'll get into right now. I'll keep this presentation short and sweet so we can all get home to our families, or like me, go have a drink. The agenda today, I'm going to give you just a really brief introduction into SkyFuel, and then I'm going to talk about what parabolic trough costs are today in China and where we want to get to in the future. And then I'm going to put forward a roadmap that identifies some very specific strategies that we have identified for achieving significant cost reduction. And then I'm going to wrap up with some conclusions. There we go, that's much better. Okay, so SkyFuel, for those of you who don't know, we are a United States-based company that was founded in 2007, really with one mission in mind, and that is to provide the lowest cost thermal energy generation from a parabolic trough system possible. We do this by providing an innovative parabolic trough technology that we designed in the United States, and we just so happen to manufacture it in China at a very low cost. What we do as an organization is a variety of things. First, we provide engineering services for parabolic trough solar fields. We also provide manufacturing of parabolic trough equipment and deployment of complete solar fields. We can really function in one of two ways. We can either just provide equipment, our parabolic trough technology, to projects here in China or around the world, or we can provide more turnkey solar field solutions for those in need of that approach. Interesting, okay. So we work in a variety of applications. We focus, though, on hybrid power generation, interconnecting parabolic trough systems with other thermal sources. For example, biomass, geothermal, coal, natural gas. The project picture here is a combined cycle natural gas project that we interconnected with one of our parabolic trough solar fields in the country of Canada, actually. This first picture is the farthest north operational parabolic trough project in the world to date. So it experiences very cold temperatures, which are found in some of the northern climates here in China as well. Of course, we work in other applications, such as power generation, such as industrial process heating, combined heat and power, as well as desalination. The picture on the bottom right is a desalination project that we built in the state of California. We can deploy parabolic trough technology using either oil, HTF, which is pictured here on the left, or molten salt, HTF, which is a prototype system pictured here on the right. We have been active in molten salt parabolic trough development for a number of years now. We really started with that approach in 2011 with a large grant from the United States Department of Energy to develop a parabolic trough specifically for molten salt use. This resulted in a new parabolic trough design that we prototyped and installed in 2013. This molten salt test platform has been operational since. We've been able to test a variety of molten salt components within parabolic trough systems at this test platform, including flex hoses, receivers, heat tracing, which we just heard a long presentation about, and other elements as well. But what I really want to talk to you about today is something that's very important in order for the future success of parabolic trough systems here in this market, and that is cost reduction. Of course, we are all estimating the tariff rate for this first round of the program maybe to be around 1.1. But of course, that is not going to remain steady forever, as it shouldn't. Costs need to come down, and the tariff rate that is provided to CSP projects will come down as well. So today, we estimate deployed conventional parabolic trough systems in the Chinese market to really price in at around 850 RMB per square meter. Now, this is a decent price in the historical context of the CSP industry, but this is also not the future. We need to bring the deployed cost of parabolic trough systems lower, and our goal is to be able to provide complete deployed systems for around 700 RMB per square meter. So how are we going to get there? Well, we've identified 7 strategies that we're working on right now to put forward a next generation parabolic trough collector for this market. These 7 strategies are listed here, and I'll speak briefly about each one. First, increasing the concentration ratio of a parabolic trough system. This table here shows some of the common concentration ratios for existing technologies such as the Euro trough, snare trough, our Sky Trough, and our next generation collector, the Sky Trough DSP. Of course, concentration ratio is just the aperture area of the collector divided by the aperture area of the receiver. By increasing the aperture area of the collector, we're able to achieve a variety of cost savings. In our new design, we've increased the aperture area from 6 meters to 7.5 meters. What this does is it allows us to achieve a variety of cost savings. One of the most notable, though, is the reduction in quantity of components that are needed. For example, in this table, for a representative 50 megawatt project with 4 hours of thermal energy storage, we're able to reduce the receiver count by increasing the aperture from 6 meters to 7.5 meters by 2,736 within a project. We're able to reduce the drive count by 114. We're able to reduce the foundation count within the project by 950, simply by fielding a solar collector that's a little bit bigger than the ones that are common in the industry today. Of course, the cost benefits of this are lower quantity of components and reduced balance of field costs such as foundations. Next is increasing the receiver length. I just heard a really interesting presentation from Nick at Royal Tech on their production equipment that allows for receiver lengths up to 5.4 meters. That's fantastic, and was really music to my ears, because by increasing the receiver length, you're also able to reduce the quantity of components within your system. In this same 50 megawatt representative project with 4 hours of storage here in China, we're able to, by increasing the receiver length from 4 meters, which is the industry standard today, to what we use within our collector, 4.722 meters, we're able to reduce the receiver count by 2,300. We're able to reduce the drive count by 96. We're able to reduce the foundation count by 800, simply by fielding a solar collector with a little bit longer receiver than what is common in this industry. Next is a focus on optics and efficiency. This is really important because every improvement in efficiency, of course, is an improvement in the actual thermal output of the solar field. And an improvement of this, of course, improves project economics as well. Now, what do I mean? This means focusing on the optical quality of the mirror, focusing on proper alignment of the mirror, and using a technology that will maintain the proper mirror alignment for the duration of a project. Picture here are two, these are actually Trough modules that are photographed using a common process called the distant observer method. When you stand at a certain orientation to the solar collector, you should be able to actually see the receiver reflected on the mirrors. And that's what's pictured here. The top picture shows the top rows of mirrors are not really aligned very well because you don't actually see the receiver, which is going to be that dark bluish color. You don't actually see the receiver in the mirror. This means that light reflecting off the mirror surface is not striking the receiver. This dramatically reduces project efficiency. This is, of course, not acceptable to have positive project economics. The picture below is a better aligned module, and this is what we typically want to see. Next is scale. Of course, scale is a very known entity within business and economics, the economies of scale and learning rates. There are a variety of different learning rates that come from manufacturing. This helps to improve efficiency, reduce scrap rates, reduce the time it takes in the manufacturing process, and improve quality of the product. Scale rates vary depending on the type of manufacturing you're doing and the components that you use. Some of the different learning rates are listed there in that table. We estimate that in the parabolic trough manufacturing business, for every doubling of your production output, you will achieve somewhere between 10 and 20% cost reduction through what I just mentioned, reducing scrap, improving efficiency, and so forth. And this is also very important for this industry, that we have a consistent supply of projects so that we can plan production appropriately and begin to scale up the industry. This will also, of course, reduce costs of parabolic trough manufacturing. Okay, so next is, of course, and something that we focus on as an organization in everything we do, is innovation. Reducing cost to the levels that we need to grow this industry is simply not possible by replicating what is currently available today. We need to think about what technology is of the future. And that is what our organization is orientated around, is innovation within the parabolic trough business. We need to foster a corporate culture of innovation and not replication. This means that we need to ask questions at all levels of the organization. We need to ask why. We need to ask what if. We need to ask how might we. And these questions should not be taboo within your organizations. These should be promoted within your organization. And then we need to validate these ideas through testing. We need to validate these ideas through research. And then we need to prototype them, and we need to independently test them through third parties. This is the strategy for innovation and finding out what works. I want to give you a specific example. What we have, an innovation that we have brought about within our own parabolic trough design. Historically, parabolic trough systems have used glass facets. These glass facets require 4 attachment points on the back. The glass facets also require precision jigs and fixtures in the assembly process. They require optical alignment. They require a dedicated assembly building on site to put them together. What we have done through using a flexible, flat mirror that slides into our parabolic track system, we have eliminated the need for any type of optical alignment of the mirror. We have eliminated the need for any tooling required. We have eliminated the need for an assembly building on site. This is simply through one change to the mirror of a parabolic trough. You might think about innovations in other areas of troughs, from the drive and control system to the frame, to the ball joints or flex hoses. There's opportunity for innovation in all areas of parabolic trough manufacturing. We need to identify them, we need to validate them, and we need to implement them in commercial solutions. This is, of course, another picture of how our mirrors go into place. We manufacture flat, flexible mirrors that simply slide into place. This is a really quick and easy process that, again, eliminates the need for any precision equipment or any type of dedicated building on site for assembly. We need to localize, and this is most important in the Chinese market. By localizing, you're able to, of course, very easily reduce shipping costs, reduce import fees and tariffs and so forth. But what's really important in the Chinese market is that there's a lot of incentives available for developing manufacturing. These incentives might be free land, free rent. They might be grants or tax rebates. They might be preferred product status within a region. These are things that we need to identify and utilize in order to dramatically reduce the cost of building a manufacturing facility here in China. Number 7, we need to manage technology risk. And this is important on both sides. Manage risk from the parabolic trough manufacturing side and reduce risk on the EPC side, selecting which parabolic trough technology you're going to use for your project. In the manufacturing side, what we do is we go through a very specific process of technology validation using third parties. We have been a long-standing partner with the National Renewable Energy Laboratory in the United States and have gone through a series of technology validation steps with this partner. This has resulted in a technology that we can now take to banks to get project financing. This, of course, helps to reduce risk, but also what we provide to our customers are performance guarantees related to the technology. A 20-year reflectance guarantee on our mirrors, a 5-year thermal output guarantee of the SCAs. What this does is help to reduce the technology risk of the EPC. Instead of selecting their own technology that they're trying to develop internally, or purchasing a technology on the market that does not come with performance guarantees, now they can be confident that if the technology does not perform as expected, they are not on the hook. The manufacturer, we are on the hook. This will help to reduce the technology risk of your project and improve the availability of specifically debt financing for your project. Now, in conclusion, again, thank you for your time to summarize the points that I've made, that there are many ways to pursue cost reduction. Only one of the 7 ways allows for replication of the technology that's available today. So, and that is, of course, economies of scale, duplicating your production process, growing your production process to reduce cost. All the other ways means that we need to look at technologies that don't yet exist, or just in the demonstration and trial phases, or being, or sort of don't have the commercial status that others do. We need to look at what's next in this industry. We need to orientate our organization around parabolic trough manufacturing. Or if your organization is not orientated around parabolic trough innovation and manufacturing, you need to partner with one who is. And finally, we need to manage technology risk appropriately. You should not risk your market future on poorly executed parabolic trough systems or parabolic trough systems that do not come with specific performance guarantees that reduce your risk as an EPC. So that's all I have for you today. I really appreciate you taking the time to listen to this presentation. And again, thank you for CSPPLAZA for having us, SkyFuel, here at this event. And we wish you all the best of luck in this industry. Your success means success for everybody, and that's what we want to see. Thank you.